Now let's create our first PySpark demo in Databricks. We'll start from the Databricks homepage and jump into the workspace from the left sidebar. Inside the workspace, click Create, choose Folder, and name it Intro. Perfect. Now open that folder, click Create again, and select Notebook. Databricks creates a new Python notebook for us. Finally, rename the notebook to Spark, and we're ready to start coding. Now that our Spark notebook is ready, let's bring in some sample data. First, we add a quick comment at the top of the notebook to describe what we are doing. In this step, we are downloading and pre-processing a CARS dataset that originally comes from an open source dataset. Now we paste a simple shell command using wget. This command downloads the CSV file directly from GitHub and saves it inside our Databricks notebook environment. This is the content of the public cars.csv file that we'll use for this demo. You can find the dataset link in the video description, so you can download it and follow along step by step. Once the command is ready, we click Run. Databricks executes the cell, connects to GitHub, downloads the file, and confirms that the file was saved successfully. Perfect. Now the file is available inside our current workspace session. Next, we create a new cell. Here, we run a simple command to list the files in the current location. This helps us confirm that the cars.csv file is really there before we try to load or process it. After running the command, we can see the downloaded file listed in the output. Since I ran the cell twice, it generated a duplicate file. Let's just remove one of them. Now let's quickly inspect the content of the file. We create another cell and use the head command to preview the first rows of the CSV file. When we run it, Databricks displays the first records from the dataset. We can now see car names, miles per gallon, cylinders, displacement, horsepower, weight, acceleration, model year, and origin. This is useful because before working with data in Spark, we should always understand the structure of the file. Finally, we create one more cell and run pwd. This shows the current working directory. In this case, we can see that we are working inside the intro folder. Great. We downloaded the data, confirmed the file exists, previewed the content, and checked our current path. Now that we already downloaded and inspected the CSV file, let's load it into a DataFrame. First, we create a new cell and add a quick comment to explain the goal of this step. Here, we are going to read the CARS CSV file, first using Pandas, and then convert it into a Spark DataFrame. We start by importing Pandas as PD. Then we use pd.read_CSV, passing the file name cars.csv, and using semicolon as the separator. This is important because this dataset is not separated by commas only. It uses a semicolon format, so we need to tell Pandas how to read it correctly. Next, we create a Spark DataFrame from the Pandas DataFrame. This step is useful because Pandas works locally, but Spark DataFrames are designed for distributed data processing. Now we run df.show. Databricks executes the cell and prints the first rows in a text format. This confirms that Spark can read the data successfully. We can see columns like car, MPG, cylinders, displacement, horsepower, weight, acceleration, model, and origin. Now let's make the output easier to read. Instead of only using df.show, we use display_df. When we run it, Databricks renders the Spark DataFrame as a clean, interactive table. This view is much better for exploring data because we can scroll, inspect columns, and quickly understand the dataset. Perfect. At this point, our CSV file is loaded into Spark. Now that our data is loaded into a Spark DataFrame, let's see a few common ways to inspect it in Databricks. First, we move to a section called Viewing the DataFrame. Here we can compare different PySpark methods and understand when to use each one. The first option is df.take5. When we run it, Spark returns a list of row objects. This is useful when we only want to quickly grab a small number of records and inspect them in Python style. Now, the next option is df.collect. This one is important to understand carefully. Collect brings all the data from the Spark cluster back to the driver node. That means it can be useful for tiny data sets, but dangerous for large data sets because it can consume too much memory and even crash the driver. So as a data engineer, we should avoid collect when working with production-sized data. Next, we use df.show. This is one of the most common ways to preview a Spark data frame. When we run it, Databricks prints the first rows in a clean table-style output. By default, show displays the first 20 rows, but we can also pass a number, like df.show5, to control how many rows we want to see. We can also use options like truncate equals false when we want to see the complete column values. Now, let's look at df.limit5. This method does something different. Instead of returning rows directly, it creates a new Spark data frame with only the first 5 rows. That is useful when we want to continue working with a smaller data frame, apply more transformations, or display it later. So, quick summary. Use take when you want a small Python list of rows. Be careful with collect because it brings everything to the driver. Use show when you simply want to preview the data. And use limit when you want to create a smaller Spark data frame for the next steps. Don't forget to use display when you want to see the data, columns, and values in a well-formatted way. For example, you can use display df.limit5 to preview the first 5 rows as a clean Databricks table. Now that we already know how to preview the data, let's inspect the structure of our Spark data frame. First, we move to the section called Viewing Data Frame Columns. Here, we run df.columns. This command returns a simple Python list with all the column names in the data frame. Now we can clearly see columns like car, MPG, cylinders, displacement, horsepower, weight, acceleration, model, and origin. This is useful when we want to quickly confirm the available fields before selecting, filtering, or transforming the data. Next, we move to the DataFrame schema section. The schema is very important in Spark because it tells us the name of each column and the data type Spark is using. First, we run df.dtypes. This returns each column as a pair, the column name and its data type. For example, some columns are strings, some are big integers, and others are doubles. This gives us a quick overview of how Spark understands the dataset. Now we use df.printSchema. This shows the same information but in a cleaner tree format. We can also see if each column allows null values. Perfect. At this point, we know the column names, the data types, and the structure of our Spark data frame. Now let's continue with an important Spark topic, inferring schema implicitly. Before Spark can read the file directly, we need to move our cars CSV file from the workspace into a proper Databricks file location. First, we quickly verify that the file exists in our workspace folder. We run a list command and confirm that cars.csv is available. Then we check the current path, and we can see that we are working inside the intro folder. Perfect. Now we are ready to copy this file into a Databricks volume. Next, we create a volume using SQL. This volume gives us a managed file location inside Unity Catalog, where Spark can read files using a standard path. After running the SQL command, Databricks confirms that the volume was created successfully, or that it already exists. Now we create a new Python cell. In this step, we use dbutils.fs.cp to copy the cars CSV file from the workspace path into the volume path. Once we run the cell, Databricks returns true. That means the file was copied successfully. To confirm it, we run a file system list command on the volume path. And now we can see cars.csv inside the volume. Great. The file is now in a location that Spark can read directly. Now let's read the CSV file using Spark. We create a new cell and use spark.read.csv. We pass the full DBFS volume path to the cars CSV file. Then we set header equals true because the first row contains the column names. We also set separator equals semicolon because this file uses semicolons between values. And finally, we set inferSchema equals true. This tells Spark to inspect the data and automatically detect the best data type for each column. Now we run printSchema. Spark reads the file and shows the schema in a tree format. We can see that car and origin are strings. MPG, displacement, horsepower, weight, and acceleration are numeric columns. And cylinders and model are detected as integers. This is the power of schema inference. Spark can look at the data and automatically decide the column types for us. But there is an important warning. Inferring schema is convenient for demos and quick exploration, but it is not always the best option for production pipelines. If you read multiple files with slightly different structures, Spark may infer the wrong type or create unexpected null values. That is why, in real data engineering projects, it is usually better to define the schema explicitly. Now let's move to the next section, Defining schema explicitly. First, we import the Spark SQL types. These types let us describe each column manually. Then we create a list with every column name and the data type we want Spark to use. For example, car is a string, MPG is a double, cylinders is an integer, displacement, horsepower, weight, and acceleration are doubles, model is an integer, and origin is a string. Next, we build a StructType schema using that list. Each column becomes a StructField with the column name, the data type, and nullable set to true. When we display the schema object, Spark shows the complete schema definition. Now we read the same CSV file again, but this time, instead of asking Spark to infer the schema, we pass our own schema explicitly. We still use header equals true and separator equals semicolon. Then we run print schema again. Now the structure is controlled by us. This gives us more predictable results and avoids surprises when the input files change. Finally, we use display on the DataFrame. Databricks shows the car's dataset as a clean table, and we can confirm that the data was loaded correctly. Perfect. Now we have seen both approaches. inferSchema is fast and convenient for exploration. Explicit schema is safer and more reliable for production data pipelines.